Hello everyone! For today's topic, you are going to learn the production of nuclear energy. So what is nuclear energy? Nuclear energy is obtained from unstable nuclei either by fission or fusion. When we say unstable, meaning the number of protons and neutrons are not equal. That's why nuclear energy can be obtained either by fission or fusion. So what is the difference between fission and fusion? When we say fission or nuclear fission, it is the action of dividing or splitting something into two or more parts. Again, take note the word dividing or splitting. So for example, in this given picture, so as you can see here, we have the neutron here. This neutron causes the uranium to split. Okay, again, split meaning to divide or to break into parts, either two or more parts. How about the nuclear fusion? So when we say nuclear fusion, it is opposite to nuclear fission because the nuclear fusion is the result of joining two or more things together to form a single entity. So it is not going to break apart, but to make it into one by joining two or more things together. An example of nuclear fission is we have this what we call uranium-235. So when a large unstable nucleus such as uranium-235 is hit with a slow-moving neutron, the neutron will be absorbed by the uranium nucleus. So for example, this is the neutron hit the uranium-235. And what happens to the neutron that hits uranium-235? It's being absorbed. So what will happen next? So what will happen to the uranium? The uranium nucleus will become more unstable in a very short time, and it will break up into smaller nuclei. It is known as fission. So this process is known as fission because the uranium-235 hit by the neutron, and then the uranium splits into parts, and some of the neutrons are also releases. Nuclear fusion. Another way of producing nuclear energy is to combine two small nuclei to form a larger nucleus. Take note, combined. So meaning it is going to become one. So that's why we call it a nuclear fusion. Like this. So the neutron is going to combine with an element. Okay, so fusion will takes place. So an example of nuclear fusion is we have this deuterium and tritium. Deuterium, it is an isotope of hydrogen with one proton and one neutron. Okay, this is deuterium having one proton and neutron, an isotope of hydrogen. Tritium is an example of an isotope of hydrogen with one proton and two neutrons. So this one is tritium having two neutrons and one proton. So when deuterium and tritium fuse together, that is what we call a nuclear fusion. So what will happen? So deuterium and tritium are small nuclei which can join to form a larger unstable nucleus, which will break into helium nucleus and a neutron. So this process is known as fusion. During the fusion process, energy is also released. Okay, so again, tritium and deuterium fuse together. It will break and form a helium and also neutron. Then, during the fusion, when it's break, energy is also released. During nuclear fusion, if a very large number of fusion reaction takes place, the total amount of energy released will very large also. Information, class, the nuclear fusion only takes place in the core of the sun. It is because nuclear fusion needs 100 millions of degrees Celsius in order to fuse. What do you think is the reason why we have this what we call nuclear power plant like this? So, since the reserves of petroleum are decreasing faster, many countries turn to nuclear energy for their energy needs. Okay, so before we have our review today, let me remind you that I prepared a short quiz and I attached it in your Google Class or in your Google Classroom. So kindly answer right after our discussion today. So what is nuclear energy? Nuclear energy is obtained from unstable nuclei either by fission or fusion. When we say unstable, meaning the number of protons and neutrons are not equal. That's why nuclear energy can be obtained either by fission or fusion. Okay, class, I would like you to compare your answer or check your own answer after this slide. Thank you so much and have a nice day.